So I'm going to try to direct as much to you, but sorry if I give the back to some of the people in the left. So yes, as I mentioned, my name is Brian. Pleasure to have you here all in the audience. And of course, we're going to start with the panel discussion by introducing our expert panelists. So we'll start from the right. In this case, I have Carsten Demuth, which is Director of Digital Products and System Marketing at STMicroelectronics. I have Dr. Su-Birm, VP of Digital Vision System at Motherson. We have Damian Barnett, Global PP CTO at DXC Luxoft Automotive Solutions. And last but not least, Dr. Oliver Wolst, SVP of Automotive Semiconductors at Bosch. And with that being said, of course, there has been a lot of discussion, and of course you heard also Ola Källenius' speech where referring to the software-defined vehicle, right? What we tried to address with this panel is the automotive software and electronic platforms are becoming crucial pillars in the conceptualization of the software-defined car. What is a software-defined car? Basically, is new way of interpreting the system in which this can offer new experiences and functionalities to the customer, such as autonomous driving capabilities, customization and upgradability, over-the-air updates, and this, of course, can create, in turn, additional revenue streams and transform a car's life cycle. Nevertheless, though, today's vehicle architectures were not designed for programmability nor software updates in mind. And for this, I would like to give the word to Damian. Of course, a software-defined vehicle is sometimes a very common tag used in the industry nowadays, even oversimplified. Yes, we have heard the computer or the smartphone with wheels. But my question to you, Damian, is what does a software-defined vehicle mean in your own words, and what does it ultimately represent for the future of the automotive industry?
Thank you very much, Brian. So with regards to software-defined vehicle and what that means for the automotive industry, I would say just look around, right? Every innovation that we see here has software written over it. If we look at the products, and then we'll be, what we just saw in the presentations before as well, from Simpart here, where mirrors are no longer just a piece of hardware, their value is driven through software. The value to the client, the person driving the car and the vehicle at the end of the day, all of that is now driven through software. Software creates the true value of the car. And even if you look at it, right, when back in the day it was the motor, it was that noise, the engine, it was the feeling, right? A lot of that today is controlled through software. And so this is really, when we look at the software-defined vehicle, that it's defined now through the software in the vehicle. And the challenge, I think, here for the automotive, or the opportunity now for the automotive industry, is obviously to now be able to do that as not just a company can step in and do that on their own. We need to build ecosystems around that. And I think DXC Technology and Luxoft, with the breadth that they cover from in-vehicle software all the way to the back end, but also with that partner ecosystem in play, can really help build up the software independence that automotive players need today. They don't have that. They're product makers. They're not software manufacturers. We can enable them to gain that software independence and at the same time also scale and help build the talent that we need to really forge the future of software-defined vehicle.
And that's where the value of DXC Luxoft comes in, especially regarding this topic, right? To the expertise of the software and the development.
Exactly, because we have a strong heritage in software, both in the back end as well as in the vehicle. And by combining that together with our partner ecosystem, we can advise our clients in the industry how to do things. We can empower them to take control of their destiny, and we can help them scale. So that's the value proposition of DXC Luxoft.
Thanks a lot, Damian. And now moving on to the topic of course, the hardware architecture. Future EE vehicle requirements. Carsten, let's begin with the following statement, if you could say so. For a vehicle to be truly software-defined, the complete hardware platform must be designed having in mind this in order to enable that, that particular characteristic. So the question to you, Carsten, is in which role does STMicroelectronics sees itself when defining the future electrical and electronics architecture together with the partners in the industry overall?
Okay, thank you, Brian. So there was already the introduction of Alessandro, what we do in terms of products. So ST is really a broad supplier of semiconductor devices, from power to sensors and also to digital. What we have seen today is, of course, a transformation process in the industry, in automotive. So in the past, everything was a bit closed. We had ECUs for each and every function. And now with the new architectures towards domain, towards zonal architectures, we see a tremendous change. So that means the zonal architecture for the very first time in automotive really decouples software and hardware lifecycle. So that means you can build your hardware system, scalable hardware, but on the other hand, you really offer the opportunity to software companies to build their software packages, to update over the time of a lifetime of a car. So not to buy a car and then you stay with the software forever, but really to have this kind of availability. And what does ST bring to that context? Clearly, we built a scalable MCU platform for the next generation of zonal cars with over-the-air updatability features, with safety, with security. Virtualization becomes very important, really to have different software processes running on a hardware. And we offer to the market, let's say, a stable, long-term available platform. And there was this morning the question, what is more important, software or hardware? And the answer of Ola was both. So what we offer, of course, to the industry, to everybody, is a good and scalable hardware platform. But we invite on the same time really partners, especially here in the startup, to complement with software, with new software offers, with new applications in the car, because this is at the end of the day really the added value for the OEM to offer services to his customers and to update over the lifetime of the car.
Thanks a lot, Carsten. Moving out now to Oliver, and of course going deeper into the topic of vehicle architectures. What are the biggest advantages, also from a OEM perspective, of a vehicle centralized zone-oriented architecture, such as the one is envisioned by Bosch for new vehicle functions, such as autonomous driving capabilities and other most customizable features that you can add into a vehicle, into a car?
Yeah, thanks, Brian. It's a good question. So we all know that all OEMs within the next years are going to offer a broad portfolio of digital business models. It's about marketing product features and services in a different way than in the past. Obviously, Tesla also has been a role model in that, so that will be the future. And for enabling this, we all know it must be a software-defined vehicle. That's the precondition to enable that. And for implementing a software-defined vehicle, we already understood a couple of years ago, we need a central architecture, a central and zone architecture, because otherwise, the complexity of the software cannot be handled. To handle the complexity of a software that will be updated, that will be branched, that will be changed in the future after delivery of the vehicle, to do this on 50 different control units coming from 50 suppliers, it's impossible. It's not going to happen. We also don't have an example for that in the past. So that's why it has to go there, and it's important for the OEMs. Therefore, they started to develop the software architectures, and they had to do it in a very close cooperation, as Alessandro was pointing out, with the hardware architecture, with the semiconductor makers. And now, for the last 2 years, all OEMs and IDMs were going through this process, and the new architectures for 25, 26, years 25, 26 are defined. However, with this first outcome, I think collectively in the industry, we are not so happy. They are much too expensive. We achieved centralization, but we didn't make it lean. We had to add a lot of computing power in the central units, but we didn't manage to get the computing resource need down in the zones and the other components, so it adds on top. So the next task is now, and it has to come fast because we're talking about a lot of cost, is to come up with higher performing architectures, with leaner architectures, with cleaned up, tidied up architectures. And for that, we will need to develop virtual hardware on an IP level, on a semiconductor level, but also ECU and multi-ECU vehicle level, a complete virtual model to run software stacks, to analyze the performance of architectures, and to develop future lean architectures. And that's, I think, where OEMs, semiconductor makers, but also, yes, I'm from Bosch, also the tier ones will be required in order to manage that task. And there is a lot of cost buried in that. So I think that's the next step, that's the next challenge.
Thanks a lot, Oliver. And yeah, speaking about system input, meaning what the car perceives, vehicle sensing demand is expected to increase since there will be a higher need of capturing the environment for ADAS and autonomous driving capabilities. And my question now to you, Su-Birm, is what kind of innovations are needed on the computing side in order to bring together all these different signals into actionable data for the vehicle itself? Yes.
So the technical simple question, Brian, or answer, is what my colleagues already explained here. So centralization, more computing power, faster interfaces, lower latencies. But I think the reality, as we have learned in life, is a bit more complicated. So what I have presented in my previous presentation, that we at Motherson are developing computer monitoring system, is slightly different to what ADAS or autonomous driving systems are doing. Because we capture the world, we process the image, and then show it to a human driver or a human passenger. And that has some, I would say, different, objectives than for an ADAS system. And what we are doing right now, and that's the answer to your question, is how do we combine this? How do we create systems which can give the best human vision, but also give the best computer vision? And I think that is not only with hardware and software, but it has to do also with image quality. And image quality is very subjective, something we have to learn how to measure, how to program this in a way that human drivers, who sometimes perceive very different because they have different eyes, will evaluate the system we are developing as a very good system. And still, at the same time, have the performance we need to detect, to classify obstacles in the right way. I think these two things are very demanding, and where not just computing power or software will be needed, but also new ideas, new concepts, how to bring these two worlds together.
Thank you, Su-Birm. And now moving on a little bit about the panel hypothesis. Before, much of the vehicle software and electrical electronic systems could be done a little bit in isolation. But today, as we have been discussing, no single actor can solve on its own the technical and commercial challenges for the creation of the software-defined car. So now my question to all of you and whoever wants to jump in is, how can the different stakeholders, meaning all the companies you represent, all the different value chain across the automotive industry you represent, also members of the audience, the companies you represent, how we can all work together to energize this transformational challenge towards the creation of a truly software-defined vehicle? Carsten, we can start with you.
Maybe one comment on that. I would say, like we see here today, to have as early as possible involvement of all the different parties, so not to have a top-down process, and really to engage with hardware, with software, with tier ones, with OEMs, all together. Collaboration, this is, in my opinion, really key to manage the challenge, because software is so complex, as the colleagues already said, it's not manageable by single companies. Really collaboration and early involvement of startups with good ideas. We see here majority of the startups is in the field of software. This is key.
Thank you.
If I may add a word. I think what is important is that we are overcoming the hurdles, the borders, because these days all companies working on their own because of IP, because of ideas. But if you want to achieve what we are heading for, then how do we get seamless teamwork over the borders of companies accomplished? I think this is a challenge we have to overcome, which has nothing to do with technology or with, I would say strategy. It is more or less how do you get multiple companies working as one team with tools, with access to data, with everything.
I think a lot of it's changed already. So all stakeholders, I would say, are much more open to partnerships than they have ever been before. That's very clear. But that's actually why forums like this one have a particular value in these days, more than before. Yeah.
And if I could add, I think what the gentlemen have said is correct. So we are moving in the right direction. Look at SOFI, right? That's about a scalable architecture that helps drive the software-defined vehicle. We look at Eclipse SDV, which is a code-first try to really drive also reuse of code, right? We talked about cost. How do we bring the cost down? And it's not just the cost of hardware, it's also the cost of software. And I think, when we look at all of the players in the market, and I think it's understandable that everybody wants to understand what does it mean now for me as an OEM, as a tier one, as a semiconductor, as a solution provider, what part of the software value chain do I need to control? And I think right now what we're seeing is that everybody wants to control everything. What we need to do is come together and really focus on where do we differentiate, right? So a car company needs to be able to understand and embrace and harness the power of software, but they shouldn't be doing a base platform. They should leave that to the to the semiconductors. They should bring in software experts for the software parts, for the DevOps. They should bring in the tier ones for where they can bring in innovation. And I think we saw it also, right? How do we drive open innovation? How do we drive a more open, inclusive discussion that, again, is really focused on how do we drive differentiation?
Thanks a lot for the answers and, of course, for being here present, for making this panel possible, and precisely to start fostering this collaboration with these open discussions. And we hope, of course, to have more interesting talks afterwards in the networking and a couple of drinks, on top of it. Thank you very much also to each and one of you members of the audience for listening to this panel, and we'll see each other very soon. Thank you very much.